Okay, in this video, we're still doing linear and nonlinear functions, chapter 1, or chapter 10, section 1, but part 2, because obviously we just need a few more examples just to help really understand the layout and how a linear or a nonlinear function looks or operates. Okay, so you obviously have the same setting first, excuse me, and then linear, and you underline in red. Why do I have blue? You underline in red linear and nonlinear functions, chapter 10, section 1, part 2. Part 2. Okay, so yes, write everything down. All right, determine whether each table represents a linear or nonlinear function and explain. So here we have our table, but it's not filled in. Remember, we have some tables that are already filled in, and we just look at the constant rate of change. And then this table is not filled in, and we're going to graph it. But here we have something different that we haven't really explored before, is an equation or a function that has to a certain power. Here it's to the third power. Remember, when it's something to the third power, it's that number times itself that many times. And we're going to go over that. We're going to go over that. So as an example, here we go. I started with a negative number to show you in better detail of what this function looks like. So I have negative 2, negative 1, 0, and then positive 1. So we'll start with negative 2. So y equals 2 times, well, it's negative 2 to the third power plus 1. And I'm going to kind of elaborate on what this negative 2 to the third power is. Remember, negative 2 to the third power is negative 2 times negative 2 times negative 2. Okay, so we have negative 2 times negative 2. I'm going to move this up a little bit. Negative 2 times negative 2 gives us positive 4. You multiply that by a negative 2, and you get negative 8. So we're at negative 8 for just all those negative 2's. Then we multiply it by that 2. So right now we're at 2 times negative 8 plus 1. That's where we are just for this first problem. So negative 8 times 2 is negative 16, plus 1 is really negative 15. This is where you have to know your integers. They're not going away, and they're not going away all of high school. So just embrace them and learn them. Okay, so we're at negative 2, negative 15. Okay, and then let's keep going. We have y equals 2 times negative 1 to the third power plus 1. So again, it's negative 1 times negative 1 times negative 1. Well, negative 1 times negative 1 is positive 1 times negative 1 gives me negative 1. But then remember, we're multiplying it, so we have 2 times negative 1 plus 1. Okay, so 2 times negative 1 is negative 2 plus 1 gives us negative 1. So where you've got to know your integers. You just have to. Okay, so y equals 2 times 0 plus 1. Well, 2 times 0 is 0, so then we have just plus 1 at the end. And then we have y equals 2 times 1 to the third power plus 1. So as you know, it's 1 times 1 times 1. All that is just 1. And then you'd multiply that, you'd have 2 times 1 plus 1. So 2 times 1 is 2, plus 1 is 3. Okay, so those are all our numbers. Now we're going to graph them. Let's graph them. So I'm at negative 2. Remember, negative 2 in the x direction. So 1, 2. Okay, but now I have to go down, negative, down 15. We're going to go off the graph a little bit, but down 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and ironically, I think we're actually on the next graph at 15. And that's fine. Just an example. And then we're going to go down. We're at negative 1, and we're going to go down to negative 1. So you can see how quickly this graph is changing. And then we're at 0 and positive 1. And then we're at 1 and positive 3. 1, 2, 3. So this graph is like this. Obviously, not linear. It's very bowed, actually. So we have a non-linear graph. Why? Because the graph is not straight. Okay. Okay. Try the next one. Let's try the next one. Okay, so now we're back to something we're more familiar with, just y equals 3 times x. So, all right, so we have y equals 3 times negative 1, which gives us negative 3. And then y equals 3 times 0, which gives us 0. And then y equals 3 times 1, which gives us 3. And then y equals 3 times 2, which gives us 6. Whew. Okay, let's plug them in. So we go to negative 1 and negative 3. Remember, go down 3. 1, 2, 3. And then we go 0, 0, the origin. And then we go over 1, up 3. And then we go over 2, up 6. 6. And you can see that this is definitely a straight line. Remember, and it actually just goes on, forever in those directions. So this is a linear function. This is a linear function. Why? Because the graph is straight. Or, yeah, the graph is straight. Did I write graph is straight for the first? No, I did. Okay. The graph is straight. Okay, and one thing I want to point out to you, that'll be the first tip, especially when you get into high school, is what's different about these two graphs. So if I want to get to just looking at just how it's written, you have y equals 2x to the third power plus 1, and then y equals 3x. I want you to notice there's something different and unique about the first example than the second one. The first example has x, and I already put an arrow to it, x having a power of 3. Anytime x has a power of 3, so x squared, x cubed, x to the fourth power, x to the fifth power, whatever the power is, that is automatically going to tell you it is a nonlinear function. So that's a trick of the trade. If it has a power, it is a nonlinear function. Here, x's power is just 1. So it's just x. So it is a linear, meaning it's a straight line. And that's what we found when we graphed it. And we can prove it some more, but I'm hoping you trust me. But we'll do some more examples in the next chapter, or next section. But right now we'll leave that alone. But it just gives you kind of a trick to the trade here of linear and nonlinear functions. Now, we're going back to our tables. Instead of giving you a graph to draw, I have a table here for you. And we have to look at the constant rate of change, or to see if it's constant or not. So let's determine whether each table represents a linear or nonlinear function, and then explain. So again, we're going to try to discover if this is a linear or nonlinear function. So we go from 0 to 1, well, that's plus 1. 1 to 2, that's plus 1. 2 to 3, obviously, plus 1. Cool, easy. All right, now y, on the other hand, goes from 1 to 3, that's plus 2. Okay, and then 3 to 6, well, that's plus 3. And then 6 to 10, that's plus 4. So is that constant? Is that constant? No, it is not constant. I'm trying to give you time I want you really to think of it for yourself. But no, obviously that is not a constant. So that nonlinear, if we were to graph this, you would find that they are nonlinear because the rate of change, those numbers that we found, is not constant. It's not constant. Yes, write this down, write this down, write this down. Okay? Let's try the next one. Just another table. Okay. So, again, we're just looking at the numbers and not graphing them. You're welcome to find a really large graphing paper and do all the way up to 33, but I hope you learn how to figure this out without doing huge graphs. But, okay, so from 0 to 3, it's plus 3. 3 to 6, plus 3. 6 to 9, again, plus 3. Okay, so that looks good so far. Now we're going from negative 3 to 9. How much does it take to go from negative 3 to 9? Well, actually, it's plus 12. It's plus 12. Okay, and then from 9 to 21, again, it's plus 12. And then 21 to 33, it's plus 12. So this one is a linear function. Why? Because the rate of change is constant. Okay? So we've done this now with graphing the functions and then also looking at just tables, just numbers. Okay? So next class, I want you to have this ready to go. Is this table representative of a linear or nonlinear function? So you need to tell me it's linear or nonlinear and why. I want you to back up your answer. Okay? So I will see you next class.